Have you ever thought about how different medicine is going to be in the distant future? How much more control we'll have over our well-being? And how we could even get a diagnosis before we leave our homes? Your visit to the doctor's office will be radically changed. When you talk to the doctor in your wall screen, you will probably be talking to a software program. Your bathroom will have more sensors than a modern hospital, silently detecting cancer cells years before a tumor forms. For example, about 50% of all common cancers involve a mutation in the gene P53 that can be easily detected using these sensors. If there is evidence of cancer, then nanoparticles will be injected directly into your bloodstream, which will, like smart bombs, deliver cancer-fighting drugs directly to the cancer cells. We will view chemotherapy today like we view leeches of the past century. And if the doctor in your wall screen cannot cure a disease or injury to an organ, you will simply grow another. In the United States alone, there are 91,000 people awaiting an organ transplant. 18 die every day waiting for an organ that unfortunately never comes. Maybe even within some of our lifetimes, we could create nanotechnology that could replace diseased and/or broken organs from scratch. If your virtual doctor finds out that something is wrong, such as a diseased organ, then he might order a new one to be grown directly from your own cells. Tissue engineering is one of the hottest fields in medicine, making possible a human body shop. So far, scientists can grow skin, blood vessels, heart valves, cartilage, bone, noses, and ears in the lab from your own cells. The first major organ, the bladder, was grown in 2007, the first windpipe in 2009. So far, the only organs that have been grown are relatively simple, involving only a few types of tissues and a few structures. Within a few years, the first liver and pancreas might be grown, with enormous implications for public health. Nobel laureate Walter Gilbert said that he foresees a time just a few decades into the future when practically every organ of the body will be grown from your own cells. Tissue engineering grows new organs by first extracting a few cells from your body. These cells are then injected into a plastic mold that looks like a sponge shaped in the form of the organ in question. The plastic mold is made of biodegradable polyglycolic acid. The cells are treated with certain growth factors to stimulate cell growth, causing them to grow into the mold. Eventually, the mold disintegrates, leaving behind a perfect organ. If organs of the body, like the windpipe and the bladder, can be grown now, what is to prevent scientists from growing every organ of the body? Just imagine how many lives would be saved. One basic problem is how to grow the tiny capillaries that provide blood for the cells. Every cell in the body has to be in contact with a blood supply. In addition, there is the problem of growing complex structures. The kidney, which purifies the blood of toxins, is composed of millions of tiny filters, so a mold for those filters is quite difficult to create. But the most difficult organ to grow is the human brain. Although recreating or growing a human brain seems unlikely for decades to come, it may instead be possible to inject young cells directly into the brain, which will incorporate them into the brain's neural network. This injection of new brain cells, however, is random, so the patient will have to relearn many basic functions. But because the brain is plastic, that is, it constantly rewires itself after it learns a new task. It might be able to integrate these new neurons so that they fire correctly. While it remains to be seen, and maybe even in the near future, it is something we should be prepared for. Next time, we're going to take a look at the possibilities of mind reading. Is it magic or simply technology? Is there already ways for us to scan the mind and probe it of information? Tune in next time and we'll find out together.